I'm doing another late night live stream. It's just working on the Dorothy software. It's just for people who are interested to see what goes into building a bit of software like this, just the recreation of visualization from a movie. I don't expect people to sit and watch the whole thing. But if you're interested or have any questions or suggestions for features, feel free to drop them in the chat and I'll see what I can do in terms of incorporating them into the software. I'm just looking. You think Streamlabs would have some option to copy the sharing link, and it probably does. I've got no idea where to find it. So, I've just put in the menu that I need. I just have to quickly sign into my YouTube account and drop the link in the Discord. I don't think anyone's online on the Discord, but I'll drop it in there anyway in case you want to watch me work on this. So let's just go into your channel, visualize, in the menu that I need. You see this, I'm going to hear myself speak. Just don't like hearing myself speak. I don't know if many people do like hearing themselves speak. Anyway, let me just drop the link in the Discord and then I'll fire community up. So I'll just start by doing just a quick review of the progress so far, and I'll also open up the reference images I've been using to build this. So while Unity's loading, I'll show these. This is what I've been using. It's captured every frame from the movie. And so I can look at the colours. I know that the movie's just about 24 frames a second, so I can see how many lines. So it's like one line is generated every frame. So I know it's roughly every 24 for the second. I can use that to see the frequency that certain buttons blink. So for example, you can see the real-time button blinks about 4 times the rate as the 3D render button. The thing which I was really happy about figuring out, you've got 3 different views in this sequence, and it's very quick in the movie. I've only noticed this from looking at this frame by frame. So in the 3D render view, you've got the 3D render button blinking. The camera then pans away, and when it pans back, you've got this different view where you've got like a top view and a side view, and you can see here now the data views button's blinking, so this button looks related to this page, and then finally, on the very last screen, you've got this telemetry log, and you've got the telemetry button blinking. So that was my reason for having these 3 different buttons linked to those 3 different views. Got no idea what the position vectors and readings do, and as well as there's a bunch of menu buttons at the bottom. Let me just go backwards here. Your active burst telemetry filter. Took me a while to read that. I think it says link to, all one word. Hard to make out an exit. So obviously I can make the exit and quit the program. And I'm thinking filter. I think you can use that to filter the number of sensors. So depending on, I can use that as like the secret button for like the settings menu, so you can set the number of sensors that you see. If you've got a low end system, you can reduce it and have better performance. So since I've been designing the user interface, I've been doing it incorrectly all the time. So I'll just show what I've been doing. So when you have the preview window here, what I've meant to have it set to the 69 aspect ratio, and the fact I have it set to 3 aspect, it means it just resizes to whatever size this window is, which isn't correct. So things will misalign. So things will look fine in the editor, but then when I compile the program and run it full screen, then the things are slightly out misaligned, things didn't look quite right. So once I've set this to 69, once I've designed things, it works correctly now. So that's what I want to see. So I'll just show a quick demo of the program, what it can do so far. So this is the 3D render view. And if you hit the M key, and that's the mute. Well, in theory, the M key makes that data transmission sound. I don't know why it's not working all of a sudden. But then what you can do is you can hit the F key, so hit the F1 key. It doesn't seem to be receiving the user input very well. If you hit the F1 key, it'll randomly generate an F1 tornado. and each time I hit the F1 key, it'll generate a different shape. And I came up with my own function which varies the size and shape of the tornado, so you can generate a bunch of different shaped funnels, which can be quite interesting. And then you see an X to F2. And if you look down here, in the movie, all these lines are taken from the movie, but it has a prediction of the probability of the tornado strength. So right now, if I set to F2, you see F2 probability. If I hit F4, it'll generate the F4 tornado, and then this will go to F4, and then finally bump it up to F5. So that's everything on the 3D render screen. Tonight, one feature I'm going to work on if I have time is link this up to the arrow key, so you can press the left and right arrow to rotate this view, and then maybe have the up and down arrow to tilt the view, and then I'll see what I can do, maybe page up and page down, or plus and minus on the numpad to zoom in and zoom out. So that's the 3D render view. Now switch to data views. So we've got this now, we've got the center of rotation lined up with the center of the funnel. Something which I was really impressed with looking at the screenshots from the movie. The measure the altitude of the funnel in millibars, which I say is quite accurate. And if you look at any sort of weather chart, upper level chart, and it's all in millibars. Tend to not use exact altitudes because they'll change depending on atmospheric conditions. So what I've done for this scene is essentially set up two cameras. One which I've set to, so this is not this isn't these look 2D, but these are not 2D renderings. The 3D renderings, and then I've had to adjust the camera angle and the lens settings to make them look 2D. So this was easy enough. I just set it top-down view. You don't have to do anything special there. But since this is a cylindrical shape, in order to get it to look 2D, what I have to do is set the camera to be about 1.5 kilometers away. I think it was actually almost a mile away in the in-game unit. And then zoom in loads, and then that gives more of a 2D look. Otherwise, you kind of start to see the, going back to the 3D rendering, it's kind of this top bit here where you can see that you're looking at it at an angle. So that's the data views. This one, this page has slightly lower performance just because we've got rendered two different views of the funnel. And finally, I've got the telemetry data. So as you can see in the movie, let's compare that to this. You can see that all the columns scroll. It's 3 columns of 6 digits each, 4 groups of them, and all scroll at different times and different intervals. So I've got the same thing there. And look at that, I've put about 2 lines every frame. So I've got the same scrolling speed there. So tonight, some of the things I'm on to work on, in the movie, there's a sound of the data scrolling by. So I'm going to put that into the game, and I've found a link to a free version of some data scrolling sound effects. So it's not exactly the same as what's in the movie, but pretty close. So I'll be including those. I want to know why there are no audio listeners. So I need to re-export these from Photoshop. So I'll probably use that for last because that's going to be just a bit repetitive of me outputting images over and over again. What are the features that I want to work on tonight? view. So I've already done it for this screen here, and I believe I've got that in my code somewhere here. Do the data view black box controller. Yeah, so that's open when Visual Studio to load up. And see I've got it here. So I'm going to need Visual Studio open anyway. Oh, and I didn't show, might be wondering what this is about. Um, Anyone who's watched Twister will know what this is in reference to. But there is an Easter egg, and I'm not going to reveal this yet, how you access that Easter egg. But when you figure out how to activate the Easter egg, you'll notice this. The bottle of Jack Daniels appears in the funnel, and you can add multiple bottles of Jack Daniels there. So that's one hidden Easter egg. Just a short preview, but I'm not going to say how you make that output just yet. So let's open up this. So we've got the lines here. So this is what I figured out from looking at the side elevation, like the data view. So you've got the top and side view, and these are all the lines which are visible during that scene. I thought the lines are output in that little window in the top right. That's what I'm talking about. In the data view, this box up here. This is what I'm talking about. And I've made it have different outputs, like the lines that it outputs are different from what's on the 3D render view. I think there may be the same between that and the telemetry view since the layout's the same. So I'm just going to combine the two rather than rewrite a whole load of code. So what I'll do is I'm just going to copy this into Notepad just so and put it side by side with the images. So let's put that there. Actually, you know what? I'm going to use Notepad++ for this. So then I can get rid of that indentation. There we go. So I'll put this on the left-hand side of the screen, and on the right-hand side, we're going to use that. So let me just put a bunch of asterisks here, so I know this is a separate view. So I'm just going to start typing out this, and then see how it compares with this here. So you have echo all sensors. So in the Twister universe, can you try to figure out, obviously it's not real science, but in the Twister universe, how exactly does this Dorothy unit work? And my theory is that the actual screen use sensors, they use 4 LR44 batteries, which are 6 volts. That's a pretty low power device. With 6 volts, I'm not an electronics expert by any means, but imagine a device with 6 volts and a tiny antenna like that isn't going to be um, transmitting data any reasonable distance. So, and this is saying echo all sensors. So what I think needs to happen is that the systems, you see there's the setup in the cornfield in the closing sequence with a bunch of transmitters and receivers. I think the Dorothy unit works as you can see that's got like a satellite dish and things on. I think that works as a proxy between this setup, this workstation here, and the sensors, which is why when Dorothy tips over and all the sensors come out, people are like, oh, well, as long as the tornado picks the sensors up, surely that's a successful deployment. But maybe not. Maybe the sensors and the Dorothy unit need to be within proximity of each other so that the sensors can um, radio the information to the Dorothy unit, and then that forwards that's got much higher power, much more powerful power supplies on it, and that can act as like the proxy between this workstation and the sensors. And it is echo, so I'm going to send out a signal probably to the Dorothy unit, which then, or maybe directed to the sensors if it's powerful enough, and then they echo it back through the Dorothy unit. Just obviously there's no way of really knowing because it's all fictional, but it's my theory of this the little bits of information which are shared within the movie. So then you have the relative x coordinate. So it's looking very similar to this we do here. Nested data multiplex signals. On frequency, then you have some frequency, and you randomly generate these. Yeah, I don't actually know anything. Is there anything in real life that actually operates in the multiple hundred gigahertz range? That seems very high for me. And receiving real time, which looks like it's here, but it's receiving real time. Then it's, I think it varies slightly. So while it looks like it's repeating the same information as it's there, I don't think it does exactly increment data with it. Then you've got echo all sensors again. Group 1AB and 4D. So this is a different scene, so it's way. And you see 4DS, so it looks like these aren't actually randomly generated. You've got AB, AC, BD, and DS. Um, the gauge this is relative Z coordinates, before it's relative X coordinates. So I'm thinking maybe I do actually, I'm not going to combine these, I'm thinking we're going to do a separate script to handle this view on the telemetry view. So it starts with echoing the sensors, then receiving, and then it receives, in this case, the X coordinates. Then it is receiving real-time incoming data. Actually, this, I think maybe the correct order should be like that before the S receiving. Yeah, because then you have that. So I think on the first iteration through, there'll be the X coordinates, then the Y, and then the Z. And so what you do is just repeat this little sequence here, and then just increment that. It'll go X, Y, Z, X, Y, Z, X, Y, Z. Um, and then I'll randomly generate these. So I'll tell you, this just uses strings in C#, so it's fairly straightforward. So I'm just going to duplicate the script. So that's the data view black box. So maybe I should have created a script. C# script. So this is the telemetry black box. Oops, I hit enter instead of double click, which means I'm going to end up with two instances of Visual Studio open, bring the system grinding to a halt. So let me just close that. Yeah, for some reason I've got it where if I hit enter on a script, it opens up in one version of Visual Studio, whereas if I double click it opens up in a different one. It's quite annoying, to be honest. I'll probably figure out how to fix that. So we need the data view black box, which is somewhat similar. It uses some of the similar things. So I'm going to take this reference out of here, and then that will likely generate a bunch of errors in here. I'll fix that after. So redirect it to the text box so we can read and write the text from it. We'll need to use the UI. Hopefully I'll not make as many stupid mistakes as I did the other night when I see myself doing this. It's quite embarrassing to realise the basic mistakes I was making and then confusing myself. Line update time again, I believe it's a quarter of a second. So I'll try to put the flow so I can adjust it later if I need to. Lines output we'll need to keep track of, that we'll need to keep track of, then all these we'll need. So I'll need to do something clever with abstract classes and inheritance at some point, but I don't want this to turn into a CS 101 stream. So first thing we're going to do, so it's going to keep track of the time, so each frame and we're going to see how long it's been since the last frame was rendered and increment this timer. And once that timer is above a quarter of a second, and let's give it a split view here. Use vertical documentation. There we go, that'll make things a bit faster. So I'll just put in the comments here and the lines which I need. That is in Notepad++. You can indent that. And the indentation's going a bit weird. I need that for reference. Okay, so let's look at the logic here. It's going to be quite similar. So it's the time since the last line in the black box's output, then it's time to output another line. So we need an additional counter here. So this keeps track of how many lines have been output. So what we'll really keep track of is whether we need to output an X, Y, or Z coordinate. So I'm just going to have a private I'm just going to call it X, Y, Z. And that will increment, but it'll obviously a slower rate. It's not going to update with every line, it's just going to update every time this is being output. So if the counter is a 0 or 0, 1, 2, 3, 4, 5, 6, 7, 0, 8, we're going to output those solid lines. So let's just use this code here. If you don't start it on else if. So it's 0 and 1, 2, 3, 4, 5, 6, 7, 8. 0 and 8. So 0 and 8. So this very quick program lesson. These little bars are a logical OR. So that means if the counter is at 0 or if the counter is at 8, then we're going to add 6 dashes to the output box. So that's that. Else if. I think this is unnecessary. Given the scoping of everything, that's, so last line output, so it should equal 1. Then I'll put the speed in real time. You can remember to increment this counter after each one of these. Actually, I can probably move this outside of this big block. Let's just continue with this pattern for now, and then I can also do a refactoring scheme if you want to see how you turn horrible spaghetti code like this into something that's actually maintainable. Probably have to revise, forgot his name, but there's a series of programming tutorials and books on clean architecture and clean code. Bob Martin, I think it is. Look at this, it's really good. Anyway, going back to this, equals 1, 1, so it equals 2. So I'll just copy this because might as well reuse that. Okay, so 2 in real time, and then let's just get rid of that. It's unnecessary. 3, then we're going to say this isn't going on here. I keep getting an extra parenthesis in it. Looking things up. So this isn't writing it directly to the text box. I'm adding this to a list. So I have a list which can hold multiple strings. And then what I'm doing is, since the box can only hold 6 lines of text before it overflows the bottom, what I'm doing is, once I've finished adding lines of text to the box, if the list has more than 6 entries in it, I just remove the first one, so that it creates a scrolling effect. So that's what that's an echo all sensors. And it's just a random thing. I can't remember if I mentioned this in the last stream, but I was going to work with some people on the Discord to source various parts and build exact replicas of the of the screen use Dorothy sensors. And what we're thinking of possibly doing is on the bottom of the circuit board and assigning each sensor like a so a group and maybe even a 6-digit string like in here. So you can maybe choose them from the movie as well. So sensor would have like 2AF and then maybe 400 just to add a little uniqueness to the sensors. Again, implement that the Pythonic way instead of the C# way. So next, it looks like it was 1, 2, 3, 4. But what I'll do is I'll randomize the letters. So I've already got code to do that. But I can do this in one block. So let's see, 0, 1, 2, 3. So if it's between 4 and 7. So it's greater than or equal to 4 and less than or equal to 7. Okay, what we need to do is if we subtract 3 from that number, we will get the group number. So output lines dot add. Let's output that number. So it will be group followed by a little bit of logic. So it will be black lines output minus 3, and then we're going to render that as a string. And then we need a I can just take this from here. Wait a sec. No, sorry. So it'll be group something, followed by maybe by a letter, then a period, then another letter, followed by the word receiving. So that'll get added, and then we'll implement the counter. So this code is horrible. I'm cringing here at my code. Not with any consistent style for anything. But in the interest of time and actually having features to demonstrate, so I'll do that. So the next one are the relative x coordinates. So we're on to now lines 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's normal formatting here. So add, and then what I'm going to do is create another node. So I'm going to say private string coordinate, and that's just going to be x, y, z. And I'll show you what we'll do with that. So what I need to say is relative, lowercase, and then we need to choose x, y, or z. So if we subtract 9, sorry, no, we don't even have to subtract anything. So we're going to use this counter, the XYZ counter, to index this. This will go 0, 1, 0, 1, 2, 0, 1, 2, 0, 1, 2. So we're going to get the character that position. So towards, and then we're going to index that. So and that'll be XYZ. So if it's 0, we'll get the first character. If it's 1, we'll get the second. If it's 2, we'll get the third. And then dash coordinate. So we'll add that. So then what we need to do is we need to increment the XYZ counter. Then what we want is if it goes 0, 1, 2, 0, 1, 2, so if you use the modulo operator, if it, like it's modulo itself, so each time we'll get, if you know what modulo is, that's the remainder after you divide. So if you divide by 3, each time it gets to 3, it'll reset back to 0 again. So we'll do that. So that'll fix that. And then then we also need to increment the last line's output. So then we've got the nested data multiplex signals, which I've already got here. Then finally, then we have a random frequency. So just copy this and put the correct line number in. Times that to be 11. So on frequency, it will generate a random frequency between 100 and 998 actually. 10999 gigahertz. That as well. On frequency, and then if it equals 12, we do set it back to 0. Or I guess we could do this. Well, that should work. I don't think it's... Oh, then we need this as well. I need to remember to reset the timer. So this is a while loop. So while the count, so the number of lines which is output is, oh sorry, this is the number of lines in that list called the output line. While it's got more than the maximum number of lines, which in this case is 6, and we're going to remove the line at the first position until it's got at most 6 entries. And so after this, so this is a while statement. It could probably be replaced with an if statement. If anyone's really interested, I can probably show some proof that those are equivalent, but not feeling up to doing a live stream on formal methods. Imagine the niche audience of people who are both interested in Twister and formal methods and programming is very small, so I can do that. I will then update the score box, and that's good. First we'll take the tally score box out, because we don't need that here. I'll add that back to the scene. Okay, this is the telemetry black box. I'll add that to the plane. Tally score box and tally black box. Okay. So hopefully everything will be working here. Let me remember to add an audio listener. Oh, no, it's enabled for this view. You know what the problem was then. Real time. Yep. Relative X, in real time. Relative Y, in real time. Relative Z, then if we go back to X again. Yep, so that's working as well. So now it's to add the sound effects. So I emailed this to myself earlier. So I'm working on 2 screens here. So I'm sharing one screen while it's on the other. So with this being my personal email account, I'm not going to share that on the screen. But I will show the website. So this is the sound effect. I think I'll issue this. Okay, that stream may well have been silent for the last however long. I've plugged my headphones and microphone jacks in the wrong parts, so I don't know if it was capturing the mic input from my laptop or if it was just again static from a headset. So I was wondering why nothing was making any sound. I thought there was something wrong with my code. So just to recap, in case there's been no audio, I've looked at in the slides in the movie, each of the frames, from the movie. I've looked at the text which gets output and written a script to output those same lines of text and randomize them a bit. Yeah, and the sound's working as well. So that's done. So the next part is adding a sound effect in from the movie. So I've managed to find one that's close but not exact. I could probably edit it at some point and get it a bit more exact. But this is the sound effect. Don't know if that's coming in very loud, but let's get that. So I believe these are royalty free, hopefully. Oh no, you gotta pay $150 a year. Sorry, I'm not paying that much for one sound effect. So I think at some point then I'll just try and recreate that sound. What I can do is open up the sound from the movie in WavePad or something like that, look at the spectral view, see what frequencies are being generated, then write a Python script to output those same frequencies. But yeah, I was going to put the sound effect in, but that I'm not paying $20 for one sound effect, which isn't even the exact match from the movie. So let's instead work on the I'm trying to remember, there's the panning of the view, which I can do. I feel like there might be other features I need to remember about. Let me just quickly click through each of these, see if it reminds me. See, let's do it with the sound on. Oh yeah, there'll be no sound on this page because there's no listener. The audio listeners are attached to the cameras. Then I'll mute that again. Okay, so next thing to do is to make this 3D view pannable and zoomable and make it so you can adjust the camera. So we'll need again another script for this, and I'll just call this render camera. We'll open it up. So what we're going to need is a reference to a camera. So it'll just be the main camera. So public camera render camera. So we need to detect key presses, and I forgot how to do that. So let me just check quickly. If input.get, okay, let me just copy that. Right, if. So it's not going to be F1. Let's say I want the right arrow. So let's see if we can make it rotate right around the funnel. Right arrow. Want it to rotate anti-clockwise around the funnel. So there is code to rotate something anti-clockwise around a point. So let me find that. Rotate anti-clockwise. So it's a transform.rotate around. So let me just copy this for reference. Go to the render camera. So what I want to do is we want to get this camera that we've got a reference to be the main camera. So we'll do render camera. Then we want to get its transform. Then we want to rotate around. So we're going to, the tornado spawns at 0, 0, 0. So I can just say 0, 0, 0. The axis that it's rotating around is the up axis. And then you want the amount to rotate. So the right arrow, you want the camera to rotate, imagine, anti-clockwise. So let's just set a speed for this. So let's just say minus, well, let's avoid magic numbers. Is it public float camera speed? And let's just set it to 3 for now. I've got no idea what the sensitivity will be here. So we'll say minus camera speed multiplied by the time passing to the last frame. Right. What I imagine is going to happen is the camera is going to rotate, but it's not going to point to the tornado. So, but I don't know, I might be wrong. Let's just see what happens. So we're going to add this render camera to the scene. Could just add it to the main camera there. And then render camera, main camera. Let's see what happens when I press the right button. Oh, okay. So one thing I've noticed, you can't press and hold the button. You got to press it repeatedly. It looks like it's doing what I want, but I want to make it so you can press and hold the button for convenience. Let's see, is input.get key down? Is the .get key down gets true whilst the user holds down the key? Okay, so I need to just remove that down keyword and it should work. Input.get key. So let's try that now. Oh, interesting. It's still pointing to the camera, so that's interesting. I would have thought the camera would have stayed pointing in the same direction so that you wouldn't see the funnel. That's very slow, so let's just tweak that a bit. Camera speed, let's set it up to 10, see what that's like. Still feels a little bit slow, to be honest. What about 50? That's more like it. I think 50 is a nice speed. Okay, let's reset that to the default then, so from 3 to 50. So we need to do the same with the left arrow key. So I can get rid of this comment now because I know how to do it. So this is the same, but we're just going to get rid of that and change that to left arrow. Let the script recompile. And then run the script. So we should be able to move both right and left. Yep, since he is rotating right, rotating left. So we've got that bit working. Very happy with it. I wonder what happens. So let's leave in this view, go to a different view, then come back. It remembers where you are. Okay, that's good. Wouldn't expect any other behavior, just wanted to make sure. So now we need to make it so when you press the up arrow, it pans up, and the down arrow, it pans down. So I need to think a bit more about this one. So let's do pan up first. So I'm guessing it'll be called up arrow. So where do I want to rotate around? Do you want to rotate around the origin point, or do you want to rotate about somewhere midway up the funnel? We can try both out. So what we'll need to change is this, because we're now no longer rotating around the up vector. So when you're spinning around, you imagine a pole sticking straight out of the ground, pointing up. Essentially the camera's attached to that as a rail and orbiting around that. But this is going to be interesting as well, because the axis it rotates on is going to depend on where it's rotated around. So you got up. What are the other fixed vectors? You got up, right, and forward. Let's try forward. I've got see what that does. Because I need it in relative coordinates, not absolute coordinates. Okay, well that worked. I see, this is what I was worried about. So now it's rotating around the same fixed point, even though the views change, and that's not what we want. I could probably Google this quickly, find out. Unity, rotate camera up and down. Let's have a look quickly. Transform.rotate. Means rotating around the x-axis. Let me just try this, see if it makes any difference. Oh no, no, we're not moving the camera up, we're not rotating the camera itself. Want to rotate camera around, point up and down. Let's read the transform. So transform.up unity. Let's have I'll pull the documentation up here. The green axis of the transform in world space. So see, we don't want this in world space, we want this in relative space. So let's just go to transform and then we'll look at the properties it has. Got the green axis. Let's have a little read here. And the blue axis. Okay. The red axis. So see, these are all world space, whereas I don't want. So what the problem is, I can show here. So you've got three axes here. You've got the x-axis, the y-axis, and the z-axis. So it's simple enough. If you want to rotate the camera around, and looking at this here, if you want to rotate the camera around, you just rotate it around the y-axis. Whereas if you want to rotate it up and down like this, you can rotate it around the z-axis. But the problem is, that's fine if the z-axis is 90 degrees from your point of view. If the z-axis is like this, it's then starting to want to like spin it this way, and that's not what we want. We want we could take the up axis and rotate it 90 degrees relative to the camera. Try to think this in terms of vectors. So you've got, let's see, we've got a camera, main camera, and we've got the origin point somewhere over here. We want to make it so that it rotates. If you have a vector pointing to it, you want to rotate up or down. I think I have to do something with the dot product here. So if I have a vector from the camera to the origin and a vector going straight up, we need a vector that is orthogonal to those two vectors. I'm sure isn't that what the dot product does? Dot product orthogonal, is that right? Or is it the cross product? The cross product is defined as a vector that is perpendicular to both A and B. Okay, so how do you get the cross product in Unity? Unity cross product. Vector 3 dot cross. Okay, that's what we want, I think. So what we need to get vector from camera to origin. So we'll say vector 3 to origin. Well, I guess that is the transform position of the camera. So vector 3 rotate point equals vector 3 dot cross. So we need the render camera dot transform, and then vector 3 dot up. That'll give us transform dot position. Sorry. That'll give us a vector orthogonal to that, and then vector 3 dot. Nope, don't need that. I can just say rotate point. In my head, that makes sense. By some miracle, this works. I'm going to be very happy. So, I guess I've got nothing to do but to test it out. So first I'll rotate this way, and now that, oh, that looks, hey, it worked. What little bit of vector logic I can remember actually worked, and now I just need, I'm actually really happy with myself. Can't believe that can't believe that worked. I even remembered that. So that I've just done there, didn't learn from Unity. I actually learned that from writing some scripts in Kerbal Space Program. Writing a script to make a rocket hover over a certain point. I had to do a lot with vectors, and I had to use the cross product at one point to do something like that, but I'd completely forgot. That was like early 2019 I did that last, so I'm surprised I even remembered that. So next is down arrow, and then there'll be somebody to show, oh, there's like one line of code in Unity which does this for you, but I'm not aware of it, so there's nothing wrong with reinventing the wheel if you're learning. So when you're learning about dot products and cross products, and ask when am I ever going to use this, if you ever want to rotate a camera around a point using the Unity API, that's when you'll use it. Also, interestingly, it's used in the, what do you call it? It works now. Don't know if I should set limits on. Can you get into Gimbal Lock with this? I think I managed to create some form of Gimbal Lock. To rotate all the way back around again. Now it's stuck. Okay, so there's an interest. So okay, well, I felt like I had a clever solution. Appear to be experiencing some. Is Gimbal Lock the correct term? I've got two axes which have overlapped, and now I can't rotate it. How can I avoid that from happening? The problem occurred when we managed to rotate down below the plane. So we need a way of getting the angle between the camera and the up axis. I forget how to do this, so I'll Google it. Unity angle between two vectors. Vector 3 dot angle, that's handy. The vector from which the angular difference is measured, vector to which the angular difference is measured. Let's have a look at that. Okay. We don't want the angle to be more than 90 degrees between the up axis and the down axis. Also don't want it to be less than, say, 1 degree, because I think that's what's creating some of the issues. So it's just vector 3 dot angle. So we need to do, so up, and we need to add some protection in here. So let's just add a regard statement to here, and vector 3 dot angle between render camera dot transform dot position and vector 3 dot up. So it has to be greater than or equal to 1. If it's less than 1, then it won't let you rotate up anymore. And then I just need to add the same thing here, so 3.angle vector 3.up, and that should only do it if it's less than or equal to, let's say, 89 degrees. I'm assuming it returns the angle in degrees as well. Let's actually double check that. Oh, the angle in degrees. Okay, excellent. So if that's done what I think it has, so I can rotate right and left, and rotate up, and then we can rotate down. Then we don't get into that weird position before where you end up with everything inverted. Okay, I'm happy with that. So next is zooming in and out. So I can either zoom with the camera, I think. Can you zoom with the camera? Because I haven't got this set to a physical camera. I could change the field of view. That'd probably be the easiest way rather than trying to physically move the camera. Into the field of view. Or would it look better if I actually move the camera? I think it'll look better if I move the camera. So that's going to use the plus and minus. So we need to move it along the vector that it's already pointing. In indexes. Get key. Key code dot keypad plus, I think we'll use. Then again, depending on the laptop people are planning to run this on, and they may not have a numpad, so maybe I should do page up and page down. Let's do page up and page down. Page up. Imagine page up to zoom in. I could do equals and minus. Let's just do equals and minus because that's plus and minus. So equals. Okay, we'll have to add some protection in there so you can't zoom through the center, because then that's going to cause all sorts of issues. But I'll add that in after. Let's just make sure I get the code working. So I need to move the camera along the direction it's already facing. So render camera dot transform dot position equals new I guess I'm gonna say plus equals. Can you do that to a transform? Render camera dot transform dot rotation. Oh, that's a quaternion. Quaternion. How do you pronounce that? Quarter of an onion. I don't think that's definitely not correct. There's some. I remember you can add a position to a rotation as long as one's on the left hand side and one's on the right hand side, but I forget. Let's just try this. So say Unity move object along vector. I'll say Unity move camera in direction it is pointing. Okay, this Alpha Personas Forum's got a solution. So what we're going to do is we say the position equals its current position plus transform dot forward multiplied by, and I'll do that as the camera speed times delta time. Okay, let's see if that works. I might need separate sensitivities for the arrows and the zooming, but let's see. Let's try zooming in. Oh, there we go. But then what I imagine is if you go past the center point, now rotating the camera is going to create all sorts of issues. Yeah, and now, yeah. So what we want to do is make sure that the camera is not within that cube, or at least, okay, what's the dimensions of the cube? 115 by 115 by 115. So we don't want it to be anywhere within the diagonal of this. So the diagonal distance from the top of the cube to the center, let me just figure this out, it's Pythagoras. So we've got the center of the tornado here. We don't want the camera to be anywhere within, imagine a circle around here. So I just need to figure out that distance there. So we know this distance and we know this distance, so it's just the square root of those added. So 115, so let's just do this. 115 over 2. And we'll square it to the power of 2. Times by 2, then we'll take the square root of that. That's not right. Oh, is it? No, that's probably right. So let's just round it up to say like a nice round 85. So we can't get closer than 85. So to get the distance, so that's just the magnitude. So render camera dot transform dot position dot so the magnitude is if you imagine a straight line from the camera to the center of the tornado, the length of that line is the magnitude. So you can zoom in as long as the magnitude is greater than, what did I say, 85. So this should stop that. I realize I think I'm going on for about an hour now, so I'll have to end the stream pretty soon. But let's just do that and zoom in, and I shouldn't be able to zoom. Okay, maybe. So the code is right, my mathematics is wrong. It's 115 wide, 115. I could do the same calculation again. 115 squared plus 115 squared, that's the same as times it by 2. Take the square root of that and then divide that by 2. Again, I'm getting 81. Maybe I just need to experiment with some numbers. Say 100 then. Zoom in. Still let me zoom in a little bit too far. Let's see. Say 150. That should do it. Line it along the diagonal and then, yeah, I think that's fine. So now I just need to make the zoom out button. So now that we've already figured out the logic for this, I can just reuse this. Equals, and this is minus. don't want the camera to get too far away. So as long as it's less than, let's say 500 to start off with. Let's move it backwards along that vector. Let me just reset the view as well in the editor. Game object, align view to selected. There we go. Okay, so we can zoom in. So let me zoom out, unless I've got that number set too small. What actually is the distance from the origin? It'll be the square root of the sum of all those. The sum of the squares of those. So 67 times 67 plus 102 plus 102. Sorry, 102. 67 times 67 plus, let's say 103 times 103 plus 85 times 85, and we'll take the square root of that. That shouldn't be the issue. And is it giving me any sort of error? No. It must. Oh wait, minus 500. That's the error. There we go. When I went to hit the minus key before, I must have accidentally knocked it on that line. So I can zoom in and zoom out. Let's see how far it lets you zoom out. Okay, so that's you customize the view there. So I'm happy with that. So tonight what I've managed to do is get the custom text in the telemetry view, and then make it so you can control what you see in the render view. And just one more time, there's the secret Easter egg, and people are trying to figure out how to activate that. See, it's a bottle of Jack Daniels, and it's never hitting the ground. So I will be selling this software. I'm going to implement some basic copy protection. So whoever buys it, it'll be registered to a particular PC, but you pay for access to the program. So if you want to use it on multiple computers, you only have to pay for it once, and then you just. What the plan is that I'll make the software generate a code. You send that code to me, I'll send you back an activation code, and if you've as long as you've got your order number and you're a previous customer, you can activate it on as many computers as you'd like. I'm not sure on price yet, and I don't know how long it's going to take me to finish all the features I want to do, but I imagine in the next few days or so I should have a basic version ready to be released. So yeah, thanks for watching if you did. Just doing this just to show what goes into building something like this, so feel free just to watch this on 5 times speed or whatever, just to see a time lapse of me working on this. But I'm going to sign out now.